took so long to get going, but I'm sure most of y'all like the fact that it took us a while to actually get started. If you finish the reflection, you can put it up on my laptop. A couple of quick things. Say again? Yeah, that's why I said get the cards you cut out of the book.
Oh, you just said that?
It's right there.
My bad.
It's stuff you cut out of the book yesterday. Oh, that's why. Don't sweat it. We'll print something out for you, and then you can just use those cards. All right. So I see the question on the board. That's the only question I see, and then how to do quadratic equations. All right. So we'll look at those. Those are actually something I wanted to do today, anyways, as a recap. One thing I do want to quickly point out is, I know some of you are like, well, do I get points for doing a weekly reflection? Well, I mean, here's the thing. No, because the weekly reflection is one, so I can get to know you better, and two, so that I can teach you better. And so hopefully it comes out in the assessments and the grades, and so I can understand what's going on with you. Two, this is also to help you keep track of your mathematical journey. I read through these, I look through them every single week. I hadn't made any kind of comments, which is why I hadn't given them back. I think I stayed up till 12, yeah, it was midnight last night before I went to bed, just kind of reading through to make a quick note. Again, I already read through them, but these were so I could give you a little bit of notes so that you could actually see for sure that I'm not lying to you that I read through them. So what I do ask, you don't have to, it's your choice, but what I would ask is that you hold on to these reflections, right? They're numbered per week. And I want you to hold on to them to kind of see how your mathematical journey goes through this semester, right? See if you can see some growth in thinking about different things as the semester goes on, because I'm already keeping track and seeing some of those things. So we have those questions. So today, we're going to start with Hero Friday. Now I totally forgot to ask earlier this week for a Hero Friday. J Mike's obviously not here. Did he go last week?
No.
Who went last Friday?
What's it? They did go.
Oh, Dr. Johnson went. That's right. Yeah.
We're looking for the slash after Jeremiah.
Macaria.
I'm not going.
You're not going? All right. Anybody want to go today?
Let's let Miss.
I know it's a little late to ask.
I think the car should go.
Oh, you volunteering somebody?
No, he.
Macaria, you volunteering somebody?
No, I just think
You volunteering somebody?
No, I think he would have a great hero.
Who's your hero?
Sounds like Macaria is trying to volunteer.
I'm
Jamie,
not trying to volunteer. I do.
you go for it? All right. I was
It
say,
don't matter. Ain't nobody else volunteer.
I say, you all too scared to go? Why would she be held back? All right, yeah, Jamie. You got another hero in mind? Jamie.
She can't hear you.
What's it, Mr. Kenny?
Preston.
Alright, so I got two.
All right, just give us one today. And if you got a second one that you want to do later when someone else is scared to share, then you can do it then.
I don't know if I'm gonna do it. We're gonna do it. So my hero sister, cause like she's cool.
Who is Tootsie Roll? Deanna?
Yeah.
Why do you call her Tootsie Roll?
It's an inside joke up in Mr. Health class in my period.
Okay,
And the joke ain't going with it.
okay.
Because yeah, she's just funny.
She's funny.
Yeah. And then my second one, thank you, like I said. Shit, I find out I'm pregnant, bro. I'm gonna have a little sister. And
You're about to have a little sister.
yeah. And
It's
so-
exciting.
It's not exciting, sir. I've been the only Catholic. So yeah, that's gonna be my work. You feel me? Yeah, that's it.
I mean, that sounds pretty exciting to me if that's going to be your
Sir, I don't want it.
Huh?
I don't want it.
Yikes. I don't know if that's a hero or not. Okay. Thank you for sharing. Let's see here. So from there, we're going to get into the idea of equivalent functions to understand linear, exponential, quadratic a little bit better. So yes, Preston missed this yesterday. Maddie informed him today that we do have a demonstrated understanding at the end of class today. You can use the key. Mr. Hobby, yeah. So we have a demonstrated understanding on identifying the three different types of functions in tables, graphs, and equations. And so determining if a relation is a function, identifying the type of mathematical representation, and then relation, function, mathematical representation is that vocabulary there. And then this is really the target that we're focusing on with this demonstrating understanding is, given any mathematical representation, I can determine if a relation is linear, exponential, quadratic, or none of these. That's a huge priority for today. So we're going to do some more practice before we get into it. So I'm going to do a quick little reminder of the gold rush, right? So yesterday during gold rush is going to answer some of those questions. Yesterday during gold rush, we looked at the base and the height of a rectangle, and we used those to calculate the what area? The area, right? So I'm starting at 0 because, well, I'll explain a little bit more in the future, but base times height gives me area. When the base was 5, what was my height?
Wait, when the base is what?
When the base was 5, what's my height?
45.
45, and my area?
225.
225. 10, 40, and 10 times 40 is?
400.
400. 15, then
35.
35. We multiplied those to get 525. 20, no, not 40. 20 and 30 gave us 600. So remember, we're trying to get the biggest area. It kept increasing and increasing and increasing. And we got 25 by 25, which gave us 625. But then after that, we started to see some symmetry here. We went to 30 and 20 instead of 20 and 30, so it's 600. And so then we did 35 and 15, gave us 525. I should have just gone ahead and had this up here, but that's not bad. I'll fix it for the future. 400, 45, 5, 225, and 50, 0, and 0. So that was our table. We're going to look at that table a little bit more heavily in just a second. Hopefully we have notes on this. Hopefully it's a quick recap, especially if we missed yesterday. What else did we look at for this relationship between base and area? A graph, right? Now remember, when you make a graph, be careful about trying to make sure you're as even as possible when scaling your axes. And do you notice, do I have to go by 5s? Or do I have to go by 1s?
No.
Nope. And I don't even have to go by the same scale on each axis. By the way, what scale am I going by on this y-axis here?
100.
You sure about that?
I mean 50.
I would say I'm going by 50s. I'm only marking every 100, but what does each tick mark indicate?
25 or 50-50.
And so we want to be careful about that. That's actually why I intentionally did that here. Keep in mind, right, that even if I don't label this one, it's understood to be 50. So take advantage of using that kind of strategy in the future. But 0 map to 0, 5 map to 225, 10 to 400, 15 to 525, 20 to 600, and I made 4 decisions, 25 to 625, the worst decision was not having this ready to go, my bad, y'all.
Yeah.
It's quick enough. Alright, so what did we call this shape right here? A parabola. And that parabola is the shape of what type of function? Quadratic. What did we call that point at the very top up there? The vertex. And what did I call this thing? Line of symmetry, right? So, we have our parabola. That's that quadratic function. It has a vertex, has a line of symmetry. What was something else we said about that parabola yesterday? It started with a C. It is symmetrical, but it was something that tied into the normal distribution that we looked at. It was concave down, right? This one's concave down. It can also be concave up. But there's all of that information. And then we wrote some equations at the end of this. Now, I think, Cameron, you asked how to do quadratic equations, right? Be aware, I'm not going to ask you to write quadratic equations yet, so don't sweat this too much. The only thing I need us to be able to do is to recognize a quadratic equation. I think one thing we looked at was this one yesterday. Does anyone remember what I called this form of a quadratic? Remember, that was the base times the height, but I rewrote the height as negative b plus 50. Anyone remember what I called that? So I need us to pay attention to this because it's going to pick up on Monday. What's happening here? They're being multiplied. What's a term, a name or a term for what the things that we multiply? They're factors, right? This is known as the factored form of a quadratic. Remember, I pointed out that this factor would, just on its own, would be what type of function? Isn't that linear? Y equals mx plus b, negative 1b plus 50. So a linear times a linear gives me a quadratic. I distribute here. And I got negative b squared plus 50b. And this was known as that standard form. What was critical about the standard form for a quadratic? What about that exponent? Because remember, we've had an exponent in the past. Remember that highest power is a 2. A quadratic has an x squared. And so Cameron, as of right now, I just need you to recognize, hey, if I'm multiplying two linears, it's quadratic. Hey, if it has a highest power of 2 in standard form, it's quadratic. That's all you have to know right now. We'll go into more details on that in the next set of lessons. Okay? Last thing, but most important, this is the most difficult one to see, right? Quadratic on a table. Right here. This is plus 225, plus 175, plus 125, plus 75, plus 25. And very clearly, is this constant additive? No. No. But was there still a pattern?
Yes.
What was that pattern? What was that pattern? What? There is a 25-ish something in there. Okay, so when I look here, all these purple values are being subtracted by 50, right? And so that is, how would I describe this minus 50?
Constant rate of change.
Not the rate of change, but it is constant additive. Remember, it's not a factor because I'm not multiplying. But I mean, it's minus 50, minus 50, minus 50. Isn't that constant? And it is additive. Subtraction is a type of addition. But right here, what type of function had a constant additive rate of change? What type of function had a constant additive rate of change? Linear. So this is linear. But that's not a function. We need to recognize it. That's not a function. So it's a linear, what are we doing with that linear set of values? Adding. So a linear additive. Notice the only place I've used the term rate of change is right there. Okay, it's a linear additive rate of change, making this what type of function again? Quadratic. For the person who asked that question right there, what type of function is this, really quickly?
Quadratic.
Why would this be quadratic?
Because the power is 2.
The power is 2, right? So notice this is the most simple quadratic you could ever have. It is quite literally just x being what? Squared, okay? I can easily make a table for this. Any ideas how I'm going to make this table? Well, but so it's not that one. I will say this, I would start with a 0, but what am I going to call that 0? It's got an I word.
Input.
That's my input, isn't it? Guys, if you ever want points, if you ever want a table, if you ever want a graph, you can always put inputs in and get outputs out. If I substitute 0 in, what's 0 squared? 0. 0 times 0 is?
0.
And so be careful, this isn't raised to the 0, it's 0 times 0. What's 1 squared?
1.
2 squared?
4.
3 squared? What is it? Say it again. 9, there we go. Whew. What about negative 1 squared?
Negative 1.
So remember when we squared it, it's negative 1 times negative 1, which would be a
Positive 1.
positive 1. Negative 2 squared.
4.
4. Once again, I want to point out, you see how there's symmetry around this 0, 0?
Yeah.
Right? That's a huge hint that is quadratic. But more importantly, right here. Is that constant additive? That
Yes.
brown? That brown is the constantly adding the same amount every time? No. But what is happening to that brown? That's adding by 2. This right here is what? Constant additive. Be careful. I'm not going to call that a rate of change. The rate of change is only the first set, so that I don't get confused. This is constant additive, so what does this have to be? What had a constant additive rate of change? Linear. So this is a linear.
Rate of change.
Do note, this is linear because this is constant additive. But it's the rate of change, so this linear is an additive rate of change. Okay? So if it is a quadratic function, what type of rate of change does it have?
Constant additive.
If it's quadratic, it has a linear additive rate of change. There is eventually some constant, but remember, what type of function had a constant additive rate of change? A linear. That's why this is not a linear function, this is a linear additive rate of change. Because we're doing quadratics right now. So if you have a quadratic function, Caden, what type of rate of change is it going to have? What about yesterday or the other 2 times that said it today? What about if it was still written on the board? What about if I move closer to it? You don't see anything about a rate of change up on that board? The what? I mean, there's a rate of change there, but like, do you know what abbreviation I usually use for rate of change? ROC, rate of change. Do you see it on the board now? What is it? Okay, come up here then. Circle where the rate of change is identified. Like I've written it. Alright, can you walk up here for me? Just trust me for a second. No, you point to it. Come on. I know, I'm trying to help you. Let's go. Stop making it weird. You're making it harder for everybody else. Let's go. So you want me to do all the work for your learning? You don't want to put any work for your learning? Come on, can you help him out?
Wait, you want to raise your hand?
Yeah.
Right here?
You mean right there where it says ROC for rate of change? Okay. All you had to do was walk up here and circle where it said ROC for rate of change. That's all I was asking you to do, and you made it way harder than it had to be. Just because you weren't paying attention doesn't mean you can't learn after that. If you just trust me and do what I ask you to do, you still could have gotten there. Alright, so if we have a quadratic function, Caden, what type of rate of change does it have? No, what type of rate of change? What does it say before that ROC? She just circled it. What are the 2 words before ROC? It's linear additive. Rate of change. That's quadratic. Alright. Woo! Now we got through that. We're doing samesies at this point. We need to have those cards out. Really, I will say this. I know everyone cut it out. But I need 1 set of cards per group because I don't want you to mix and match them. I want us to keep them straight. So y'all decide whose cards you're going to use. You're going to undo all of them, and you're going to get a little messy, but stay organized with your messiness. Yes, ma'am. No one of y'all's group has a set of cards? Huh?
I wasn't here today.
Oh, yeah, I do. I got it.
Thank you. Okay. So, looking at these cards that we have cut out, all right, we are going to, by the way, this is one of the pages you tore out yesterday. Was it page 31, maybe?
Yeah.
Page 33. Okay, so you should have page 33 torn out. Please get that page out. It looks just like this, right? You score this page out along with the pages that you cut?
Well, yes, I saw it, and it's very neat. It says 2.1.
What's up?
Huh? Page 33. M1-33. Okay.
Was this just on the ground?
So looking at page M1-33, I do want to point this out. There's some key vocabulary here that they have used that we already know. What is a relation? What is a relation? The mapping between a set of input values and output values, right? That's how we've always talked about it, right? 1 maps to 5, or -7 maps to 3. That's the mathematical language there. Now, the definition they use for function, I want to clarify a little bit, but notice a function is a what? Relation, such that each element of the domain. Anyone know another way that we have actually talked about the elements of the domain? What we've called those? Someone said it? I thought. Yeah, but functions, but like, what's the domain of a function? It's the set of all, huh?
FX?
Not fx.
Okay, you're wrong.
That's it right there.
This case, all values.
Listen, guys, the elements of the domain. Y'all studied domain last year. I promise you. You have Miss Williams. I know you studied domain last year. There is something about domain and range, yeah. Domain was the set of all what? It started with an I. Inputs. Domain, sorry. Sometimes injured. Guys, domain is the set of all what? Inputs. Your range is your output. So what they're saying here is each element of the domain, so each input, there exists exactly one and only one element in the. So what's another word for element in the range? Output, there we go. Woo. Domain and range, inputs and outputs. That's what we're referring to there, okay? Now, what we are trying to do is find equivalent relations, right? So you've already cut out the relations at the end of the lesson. Analyze each relation and then create groups of equivalent relations. One quick note I want to make is, right, so you are looking for what again? Equivalent relations. All right? I'm going to make a suggestion to you to help speed things up. Will a linear function ever be equivalent to a quadratic?
No.
Will an exponential ever be equivalent to a linear?
No.
So if I were you, I might look for my types of functions first. So hear me again on that. Look for your types of functions first. Sort these by types of functions. Then identify the equivalent relations. A note on that is every group has at least 2 and no more than 5. Okay? So every group has at least 2 and no more than 5 in a set. Okay? So maybe you think, hey, I think relation A goes with relation F with relation C. And so that would be a group. Okay? So you're going to sort these out. You're going to find the equivalent relations. And we're going to write our groups up on the board. Does that make sense? Questions? No questions.
Excuse me, can you give me a book?
You are going to identify equivalent relations.
Thank you.
No problem.
Okay, the way we're going to do that is you're going to sort these. All right, so remember, 1 set per group so we don't get multiple mixed up. You all decide whose you're looking at. Makaria, since you're on your own, why don't you jump in with the 9s? Let's get up, let's get going, and get as far as we can before lunch. We'll keep working after lunch. Now, only one of those equations is equivalent to this table. Don't say anything. Which of those equations is equivalent to this table? No, y'all. We didn't talk about this. I know we didn't do this one, but hold on. Hey, if your eyes are not on this board right now, you're not learning the thing I need you to learn. So, two linear equations, linear functions. This table is only equivalent to one of those two. Which one? Exponential. Sorry, I just said linear. Which one? The second one? Yeah, why do you think the second one?
Can I do it? Can I do like negative for the constant rate of change?
Is it -2 for the constant rate of change?
No, it's supposed to.
I
Wait,
mean,
no, it's not in my, no,
no, it's
it's
-2.
It is -2, but my,
And then the -4, it go right there with the 0 for the y.
so we got a y-intercept there, right? Anybody else want to add anything onto this?
You're adding a 5 on the x's.
Okay, do I need to address that +5 on the x's?
Yes.
I'm smart.
Okay, -2 divided by 5, right? That's my slope. My y-intercept's -4. The other thing I would point out here, and I want y'all to note this, is if I substitute 10 in, what should I get out?
-4.
I mean, -8.
If I substitute 10 in, I should get out
Oh, it's
-8. If I check that top equation, in that top equation, what do I get out when I substitute 10 in? 37. Is that what's right here? No, so they could not be equivalent, right? Remember, equivalent means they look different, but tell the same story. So what do we know about their inputs and their outputs? They gotta be the same, okay? So I want you to keep that in mind. Notice, this input of 10, does it give me an output of -8?
Yes.
So, please note this and hear me clearly on this. The first thing I asked you to do was to identify your linear, identify your exponential, and identify your quadratic. Because can a linear ever be equivalent to an exponential?
No.
No. Can a quadratic ever be equivalent to an exponential? No. If it's not a function, can it be equivalent to a quadratic? No, because a quadratic is a type of function. So identify your types of functions first. Then, from within those groups, identify the equivalent ones. We good with that? Alright, listen. I'm going to go ahead and tell you this. I am going to let you have the demonstrated understanding on Monday. Pause. If you stay on top of it for these next 15 minutes, actively work to find these groups, and then we'll have a wrap-up discussion at the end. The second we get off task, that tells me you're not trying to learn anymore, and we're going to take the demonstrated understanding at that point. So, let's stay on it, let's get after it, let's do some learning. We've got 15 minutes to find those equivalent relations. Let's go. Everybody to be in a position to look at your set of cards, and we need to talk about strategy and methodical thinking here, okay? So I need everyone to be able I need everybody to be in a position to look at your cards right here and right now as we talk about these. So, still waiting for some of us to get near our desk so we can look at the cards, spread them out so that we can see them. We're going to look at card A first. Card A. When I look at card A, what type of function do we think we have? What type of relation, I guess I should say?
You said it's 8?
A. I hear quadratic. Anybody want to push back on quadratic?
No.
Does anyone then want to explain why they said quadratic? So we see some symmetry in there. Sorry, I'm rotating these so we can see them easily. Alright, the what has a parabola there? The graph. Okay, guys, I need us to understand. Like, there should be, when I say sort them into the types of functions, then there should be no debate about it. Sort them into the types of functions. You need to be methodical and strategic with these things, not guessing and random. intentional with what you have. And so when I look at A, what do we have? We have a parabola, a quadratic. A goes under quadratics. B, what do we have with B? Raise your hand if you're in agreement that we have a quadratic with B. Got 1, 2, 3, 4, 5. I got 5 of us. Okay. Bakari agrees. Okay, so I need someone who doesn't think it's a B to give a reason why they don't think it's B. Keep your hand up if you said if B. Keep your hand up if you think B is a quadratic. Okay, so Mel, you don't think it's a quadratic? Well, it's up on the board right now. So notice I got it up here. Hopefully you can see it. Yes to quadratic or no? Yes? Okay, so give me a reason why, and let's see if we can convince everyone else or if anyone wants to push back. Why do you think it's quadratic?
Because it has an exponent and the slope-intercept form.
Okay, so it has an exponent and slope-intercept form at the end. Anybody want to add on to or push back on that? Jamie?
If you graph from a calculator, make a graph.
Oh, hey guys, do y'all have calculators?
Yeah, so.
Could you have graphed that on the calculator and looked at it? Now, here's the thing, and I need your, so pause, yes, you can do that. Listen, I also need you to be able to recognize a quadratic just by looking at an equation. It's going to make your life easier. No, I mean, that's great. I'm glad you thought through that. That's a fantastic strategy. But why do we know that this is quadratic? Right. Okay, so when we say exponent, it's not just any old exponent. What type of exponent does it have? To the second power. Now, I will say this. I don't know if anybody else picked up on what Mel said, but Mel actually hit on a really important idea. What's after that quadratic piece right there? Doesn't that look like what? Slope-intercept form of a line? Quadratics have a linear piece to them. They do, right? Especially in the standard form. But why is this quadratic? Because its highest power is 2. Does that make sense? So raise your hand if you think this is quadratic now. Raise your hand if you're too cool to answer a question that Mr. Kenny asked. Raise your hand if you're just still confused. So too cool, got it. Good to know, guys. Come on, guys. I'm trying to give you something here. We just had someone explain why. We went through multiple things, and we can't even raise our hand and say yes. I think it's quadratic. Come on. C. Oh yeah. By the way, B went under quadratic. All right. C. What do y'all think?
Linear.
Kel, why do we think this is a linear? Okay, can anyone add more onto that or push back on that?
Constant additive.
Because we have a constant additive rate of change, right? Constantly adding 2 to the y, constantly adding 1 to the x. Okay, constant additive rate of change. We got to recognize that. You have to be able to look at a table and say, hey, that thing has a constant additive rate of change. That is what again? Linear. Now, I want to point this out, and maybe I need to set this up better in the future. But this is taking the mystery out of it, but still keeping the beauty intact because I'm being strategic. When you try to do things randomly, you get lost. But if you are strategic and methodical, you can start to clearly see where things go. We have at this point 8 minutes. Before we leave this classroom, I want you to identify every single function that is linear, every single function that is quadratic, and every single function that is exponential. Go in order. Sort, go look at A, figure out if it's quadratic. B, C, D, let's go. Tonight, or this weekend, and study what makes something linear, what makes something quadratic, what makes something exponential, what makes something a function in each representation. You have a check your understanding explicitly on that. We're going to finish this on Monday, and then we're going to do the demonstrate your understanding. Guys, use your proficiency scales. Hey, excuse me, I'm talking. Use your proficiency scales to help you study. Use your check your understanding to help you study. And we're going to come in Monday, we're going to wrap this up, and then we're going to do a demonstrate your understanding. We got to know how to identify linear, exponential, and quadratic functions in every representation.